Good morning everyone. Today we will diving into a captivating, seemingly simple yet incredibly impactful topic, rusting. We all know it, we all see it, but have you ever stopped to truly consider what it is, why it happens, what consequences it carries? Rusting. Rusting, a reddish brown flaky substance, a natural process, is a form of corrosion that can have devastating effects on our daily lives and planets. Rust, informally known as iron oxide, is formed when iron reacts with water and oxygen. It's a process called oxidation. Think of it, a metal skin trying to protect itself from further damage. In the early stages, the iron might turn slightly brown, more red, and finally flaky reddish brown rust. This process is accelerated by some factors like moisture, temperature, and presence of certain salts. Rust can weaken bridges, vehicles, and buildings, leading to costly repairs and even structural failures. The collapse of the Silver Bridge in 1967 was attributed to corrosion of steel components. Rusting can also cause immense damage to infrastructure, equipment, and vehicles, resulting in billions of dollars for repairs and replacement cost. Rusting contributes to soil and water contamination, particularly in areas with industrial activities. Rusted metal objects can be dangerous because they cause injuries and potentially breeding bacteria that can transmit diseases. Applying varnishes, paints, and galvanization coating with zinc can create a layer or barrier between the iron and the elements. Using corrosion-resistant materials like stainless steel and alloys can drastically reduce the risk of rusting. Storing metal objects in dry environments and regularly inspecting and maintaining them can help prevent dust from forming. Electroplating and cathodic protection and other advanced techniques can enhance the corrosion resistance. Rust forms on bench because of a chemical reaction between the iron or iron-containing metals like steels and oxygen in the presence of moisture. This reaction creates iron oxide, which is what we commonly known as rust. Factors like humidity, water exposure, and even condensation can accelerate this process. The iron pillar with MINAR is renowned for its remarkable resistance to corrosion. The phenomenon was attributed to several factors. The pillar, composed primarily of wrought iron, which contains a high phosphorus content, which helps to form a protective layer on its surface. This layer, along with the absence of sulfur and magnesium and the use of the force welding techniques, further contributes to the pillar's durability. The pillar contains 1% of phosphorus, which is relatively uncommon in modern iron, but the high phosphorus content, which plays a crucial role in preventing rust formation. Unlike modern iron, the pillar lacks sulfur and magnesium, which are known to accelerate rust formation. Ancient Indian craftsmen used a technique called force welding, where they heated and hammered the iron, which further contributes to the pillar's resistance. The relatively dry climate in Delhi also contributes to the pillar's resistance and prevents rust. A thin compound of layer called white and amorphous iron oxyhydroxide forms on the surface of the pillar, which acts as a protective barrier. This layer protects oxygen and moisture from reaching the underlying iron and prevents rust. For essence, the combination of these factors, including the unique decomposition of the iron, the force welding technique, and the protective layer of miserite, the dry climate, the absence of sulfur and magnesium, allowed the iron pillar to resist rust for over 1600 years.